Happy Friday. Hope you guys are having a good week. Today, what I want to talk about is validating forms. So far we've done a bunch of stuff with forms, right? So we've done, like, we talked about actual forms with a form tag on Wednesday, but you've also used all those form controls like text boxes and check boxes and radio buttons all the way back since homework 3, right? So we've been doing those a lot, and well, so far we've just been assuming that the user is going to give us good data. That is a terrible assumption to make on the web, right? Because you guys have used the web, right? You filled out a lot of forms. Practically every time I fill out a form, I fill it out wrong, and I get some big red message that says, "You idiot, come on, a state, this is not a valid zip code. A zip code has 5 numbers in it," say, something like that. And people fill out forms badly for all sorts of reasons, right? So, I mean, one reason is you could just mistype, maybe they have a separate box for first name and last name, but you put your first name and last name in the same box because you're not really reading, right? It's easy to make that kind of mistake, and you're not trying to do anything bad, you just aren't reading. Because let's face it, there's way too many forms you fill out, way too much to read. The other thing too, though, is that sometimes people legitimately try to put in the wrong data. For instance, pretty much every website now asks for your email address. And I hate giving my email address because you know what? As soon as you give your email address to some site like Groupon, you will get emails from them forever, right? So a lot of people try and, just put in some fake email address. Well, the web's it's hard to check if something's actually a valid email address, but you can check that something is the right format of an email address, right? If there's no @ sign, it can't be a valid email address. Right? So you can at least do some checking like that to make sure things are at least close to hopefully valid. So this is the basic idea of form validation. Form validation is just making sure people put in the correct stuff. Or even at a very basic level, making sure people fill out the form and don't just leave it blank. And so you can do this in all sorts of different ways. I mean, here's a little example of a form. I keep thinking maybe I should take a new screenshot, but do you guys remember Washington Mutual? Well, I don't know. This one has sort of sentimental value, so I have to keep it. If you're not aware, this was a bank that went out of business 5 years back or something. But this is a really common thing, right? You see on a lot of pages, come on, you've got to enter stuff you didn't enter. Don't leave stuff blank. You've got to enter a valid birthday or a valid email, that sort of stuff. There are 2 places where we can do this validation. So client side and server side. Basically, you can think of this as in JavaScript or in PHP. And so what client side tends to be is when you're creating an account somewhere, and you have to come up with a password, right? And all the websites that you create accounts on, basically they want you to have a secure password. And basically that means something totally unrememberable, right? It has to have lowercase and uppercase and a number and some punctuation, but not this other punctuation. That's not included. There's all these rules, right? And so if you're ever filling out one of those forms and there's a little bar that goes from red, as in your password's not strong enough, to orange to it's weak but okay, we'll accept it, to green, that's going to be JavaScript. Stuff that changes as you're typing. And that's pretty helpful because that will basically tell you whether they will accept your password as a valid password before you hit, you hit the submit button and try submitting the form 10 times. You're trying to figure out what the rules for the password are. So that's client side, anything that the user sees as they're typing, as they're, trying to figure out what to put into the form. This is also, you see this when you're filling out a form, and if you go past, start entering data in a input that's, and you leave one above it empty, that empty one will turn red and say you need to put something in here. That would also be JavaScript. So this is nice user experience because the user gets feedback right away. It's not secure though. Why might this not be secure? Yeah.
Because the user can just edit any code in JavaScript and then
Right. The user can open the console and edit your code. And so since JavaScript, right, it's running on the user's machine, the user can just change it. So it's really nice to play around with, but not secure. That can also, so it's not secure. So you don't want to just do that. You always want to have at least some server-side checking because, well, if you think about it, so when you have a form, you're filling out all stuff in those form controls, and you either have a form tag around it and a submit button, which will submit parameters to another PHP page, or you have Ajax, and you're using Ajax to submit data to a PHP page on the server. And either way, you're sending data from the current page where you filled stuff out to another page. So even if the user, didn't edit stuff in the console, they could write a whole nother page that would submit data to your page, to your PHP page, to the same PHP page that your page is submitting to. And so if a user were to do that, you'd still want to make sure they were sending you valid data. And if you put your validation in the PHP, that's how you can make it actually secure, because the PHP runs on the server, right? So nobody can come in and mess with it and change it. It's on the server. Unless you give them access to your server and an account and the permissions, they can't get at it. So it's safe if you do that. Most real websites these days use a combination. So they'll have server-side validation going on, but they'll also have some client-side validation so that if the user is not being malicious, they're just being kind of dumb and not reading the instructions, then they can be helped by that validation on the client side. But if they're being malicious and really trying to get around the validation, there's that server side to make sure it's okay. So I've got a little example here of a form that you could validate. Can somebody suggest something that we might want to make sure of? If we were using this form, we wanted to make sure the user was going to give us good data. Yes. That the zip is 5 characters and the state is 2 characters. They have a max length. Like, does that cover it? Min, right. So the max length is just the max. It's not the min. So we need to make sure, all US zip codes are exactly 5 numbers, right? And all US states, if you're using the abbreviation, are exactly 2. If you have a 1-letter state, it's not a state. So yeah, we want to make sure those lengths are exact. What else might we want to make sure of? Yeah. Right, like the zip is numbers and the state is letters, right? I think that would be important too. Yeah. Yeah, that like a user has written something in all 3 of those. Like none of them are blank. Yeah. You could have a list of states. It would depend on if you wanted to go that far, right? To create a whole list of states and check. What about should we do anything with the length of the city? So this is a slightly interesting one. I find this very personally interesting because I'm from the city of Lake Forest Park. Being from Lake Forest Park, if you count the letters in that, there's a lot of letters. I have found out that actually a lot of online forms do enforce a limit in the number of characters your city can be. It is shorter than the length of Lake Forest Park, and I am sure that is not the longest city name. So personally, I have an extreme preference for not limiting you on your city city name, because there's all sorts of weird city names out there. But it seems to be, for some reason, a pretty common thing to do. I'm not quite sure what the rationale is there. I think we've got most of the things we probably really want to check, right? So I think you guys got all of these here. So making sure the zip code's exactly 5, the state's exactly 2, that they have like something in the city, right? The state and zip have to have something in them if they're exactly 5 and exactly 2 long, right? We didn't get the types here though, like making sure the zip was numbers and the state was letters. We could do that. We'd probably need some loops, and it would probably get kind of complex, right? It would be kind of a pain to write that. And that's a kind of common check that you would want to make. So most people, when they're doing form validation, I mean, it's fine to use those basic, like checking the string length and checking that something has something in it. But most people end up using regular expressions. And regular expressions are basically a description of a pattern. So that pattern can be something like, for a zip code, it's 5 numbers, it's 5 long, and it's all numbers, say. And basically, a regular expression, you can just test if it's true that something matches the pattern, or if it's false, it doesn't match the pattern. Regular expressions are used all over the place in computer science. You've actually seen some of them before. So in your 3rd homework assignment, when we had you split the strings you were given, split the text you wanted to read, we gave you a regular expression for matching white space. If you've taken 143 and you did, I think it's Grammar Solver, where we give you a regular expression in there to help you split things on white space. These are used all over the place in all sorts of languages. So for instance, if you come back up to this first slide here, you'll notice they say Perl here. Regular expressions can be used in Perl and PHP and JavaScript, in Java, in you name it, any CS language. They can also be used sometimes in text editors for find and replace, which can be kind of handy. So I'm hoping after this lecture today, you're gonna feel like this guy here, who's like coming in like Tarzan, able to save people with his regular expressions. Regular expressions do kind of feel like this sometimes, where you're like, oh, I have to search through all this data and find this stuff. But if you know regular expressions, you can do it in 2 seconds once you get your regular expression working. So, really, really powerful. The one big downside of them is they can be kind of tough to read. They kind of look like gibberish. For instance, this thing up here, that is a regular expression. That's more complex than the regular expressions we're going to be writing. This is a regular expression that matches email addresses. And it's so long because, as you can imagine, email addresses have a lot of different variations, right? So there's always like something at something dot something, but you can have like multiple dots, like .co.uk versus .com or .edu, right? You can have all sorts of huge variety of stuff. So that's why that's so complex. So, regular expressions, at first, and even later, they're gonna feel a bit like this. It's a mess of syntax, right? I mean, I feel like this kind of looks like our regular expression up there. It's just a big jumble. So we're gonna go through today and talk about some of the different things that you can put in regular expressions, what they mean, and try out writing some. So, first of all, the simplest regular expression. The simplest regular expression, all regular expressions go between, I think this is a forward slash. I always confuse forward slashes and backslashes. That type of slash, between the 2 forward slashes, you put some text, and that will match anything with that text in it. Now note, this matches a substring. So if you have something that has, those letters in it, but they're surrounded by other stuff, it will still match that. It doesn't have to be just that string. It does have to be that string in that order with nothing else in between it, though. So, like, you can't have A, B, D, C. That would not match. You can't have like this A, B, space, C. It's all got to be exactly those three letters. It also wouldn't match A, B, C because it is case sensitive. There are wildcards. So we've seen wildcards before, right? In Glob star was a wildcard. So if you said like star.txt, that would get you all txt files, right? The wildcard in regular expressions is the dot, not the star. So dot here, it's a wildcard for one character. So not many, like star was, but just one. So dot OO dot Y is any letter OO, any letter Y. If you want stuff to be case insensitive, you can add an I after the last slash. And that I basically stands for, I think it stands for insensitive. Hopefully only in terms of case. But that will make your string match anything that contains that string in any type of case at all. There are some special symbols that allow you to choose between things. So, for instance, vertical bar, right? In Java, vertical bar, like two vertical bars in a row is OR, right? So you can kind of think of it as similar in regular expressions, except for we don't use two vertical bars, we just use one. One vertical bar is OR. So ABC bar DEF bar G, that's ABC or DEF or G. So it has to contain one of those. Why do you guys think there's no AND symbol? Yeah. And means it's concatenated? Mostly, yeah. Everything in a regular expression is already kind of anded together. Exactly. So it's like, if you want to say something and something, you just put both of them in your regular expression, one after another, and you're going to get both of them. You're going to have to get both of them. Right. So that's why there's no specific and symbol, because you just, I guess that's what you're saying, you just kind of concatenate them. Sorry, I didn't quite understand that at first. All right. So that's OR. We have parentheses for grouping things together. So these basically change your order of operations, just like in math. So if we have this expression here with parentheses, it matches Homer Simpson or Marge Simpson. If you were to take off these parentheses, the space here doesn't affect the order. If you were to have no parentheses, what would happen is you would be saying Homer or Marge Simpson with no parentheses. You also have to escape some of these characters because like vertical bar and parentheses have special meaning. There's a couple other characters we're going to get to later that have special meaning too. They're all listed out here for you. And you just need to put a backslash in front of any of these characters if you want to use them and actually print them out or match them because they have some special meaning. Quantifiers, this has to do with how many of something you have. So star here stands for 0 or more. So if I have like C star here, this will match a string, any string that starts with AB and has 0 or more C's. So it could just be AB or it could be AB, C, 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 so on and so forth. If I put BC in parentheses and my star is after a parenthesis, it repeats everything in that parenthesis 0 or more times. This is a really common pattern here, dot star. Dot star matches however much of anything. 0 or more occurrences of any character is what it'll match. So can you guys tell me kind of in English description, what is that regular expression that I've got an arrow to, like conceptually, what is that matching? Yeah. Right, anything that begins and ends with A. Exactly. Yes. Why can't I just say A dot A? Because dot only matches one character. So that would be something that begins and ends with A and only has one character in the middle. Yes. Can I just have... Oh, you mean can I have this as a valid string? So you're right. So here, we're not restricting this to having to be at the very beginning and the very end. Like, this is a substring. So you're right. This is something that, like, it's going to match a substring that begins and ends with A. Not necessarily like a string with spaces on the end that begins and ends with A. Right. So that's star. Plus is very similar to star, but plus means you have to have at least one. So it's one or more occurrences. And so there will always be an occurrence of the thing the plus is after. And finally, question mark. Question mark is 0 or 1. So like it's there or it's not there. So, you know, if you either want it or don't, the question mark is good for that. Couple other type of quantifiers. So you can put, like, if you want an exact number of something, or like between a minimum and a maximum, if you want an exact number, you just put a number in between curly braces that specifies exactly how many. If you want between some minimum and maximum, you put a minimum comma max. If you want like a minimum of 2 comma. If you want a maximum of 6, comma 6. If you like leave something off in the comma, you know, before or after the comma, it will just assume that's like infinite. That's however many you want on that side. All right, so we've been doing a ton of syntax here. I know that's kind of hard to remember. Unfortunately, we had to do that much syntax to really be able to write much of anything. But now I want to try practicing this a little bit. So I want us to write a regular expression that it's going to match Google. And like this is, if you scroll down to the bottom of your Google search results, at the very bottom, there's the word Google, and it has however many O's there are pages, right? Have you guys seen this? Okay, great. It never really gets less than 2 O's, I don't think, because, you know, that wouldn't be the word Google. Then we'd say, I don't know, goggle. That wouldn't be very good. So I want us to try writing this regular expression. There's a really nice tool called Rubular. And what Rubular is basically a regular expression tester. And it says here a Ruby regular expression editor. Well, Ruby's another language. Regular expression syntax is the same between languages, so you don't have to worry about it. We're just writing the regular expression. It's just the same as you would write in PHP or JavaScript. So, the way Rubular works is you have some examples of things you want to match. Can you guys in the back see this? Okay, getting some nods, good. The one thing I don't like about Rubular is that I think the text is a little hard to read from far away. But, so we're trying to match these things, and we're trying to not match these things down here. So, we can type in some stuff. So, if we want to match Google with any number of O's, I think a great place to start is just to write Google, right? And so now you can see over here on the right, it's matching the word Google, but it's not matching any others. So if I wanted to match with any number of O's, what should I do? What should I use? Yes? Add a star here? All right. So this is pretty good. Good. We're getting pretty close. But the downside here is we're matching goggle, because remember, star is 0 or more. Yeah. Okay, so instead of star, I could say bracket 1, comma. All right. I think that's good. I think that works, right? So that's saying 1 or more. There's a couple other ways I could write this. Could somebody tell me another way I could do this? Yeah. Plus, right? Because plus means 1 or more. So that, that would work too. What about another way? Yeah. Okay, curly brace 2, comma, after the O, right? That would work too. Yeah. I could add. We haven't talked about anchors yet. Somebody else tell me another way. Yeah. Okay, so I want to add another O and then 3 O's and then a star. Great. Exactly. Yes. So we could add 3 O's and then we could add a star. And that would mean, so that's like 0 or more of this third O with that star. So with regular expressions, a lot of times there's a whole bunch of different ways to write it. Any of those ways are totally fine. I'd say equally good ways to write this regular expression. So whichever way occurs to you and you like, you can go ahead and write it that way, just so long as it matches the right stuff. Now, there is maybe one thing that's not so optimal about this regular expression here. One handy thing with Rubular is if you want to try some other test cases, you can just type them in here. So, one thing that I probably shouldn't match if this is text I actually want to print out at the bottom of Google is, some gibberish, and then the word Google, and then, some more gibberish. I probably shouldn't match that string, right? But I do right now. I am matching the Google in that because it does contain Google, right? In a regular expression, by default, just looks at what you contain. So, that's not so great. We can fix this by using anchors. And what anchors are basically ways of saying, this has got to be the first character, and this has got to be the last character. So, if we put a caret at the very beginning, that means that the string must start with that character that you have right after it, which basically means there's got to be some sort of white space or something, no other characters right before it. And $ is the same at the end. That means that the character right before the $ has to be the last one in that string, and there has to be white space after. Yeah? So if you're how far apart are your anchors? So if I have a regular expression like this, anchor, just anchor, what this means is it will only match strings that are just JESS in that capitalization. It won't match any strings that contain Jess. So that wouldn't match Jessica, it would just match Jess.
But in that last one where you have
Yeah.
you had this document that was like Allison Oberholm name, blah 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 blah, many pages of text and it was the very end, and the name is Allison Oberholm. Would it match the
Yes. It would match the entire document because dot star can match anything. Or actually, let me think. So it doesn't return, it depends on what method you call with it. So I'm gonna show you either at the end today if we have time or on Monday how to put these in code. And then it depends on what method you call with them, what it returns. Actually, I think what I said was incorrect here. I said this would match the whole document. I think, so dot star, I believe dot doesn't match white space. So it would match the entire document if there wasn't white space, let's see, what? Oh, new lines, that's what it is, new lines. Yeah, won't match new lines. So long as you've written without any new lines, no paragraph breaks, then it would match that. Yes?
So if you put in parentheses dot or would that actually match the whole document?
If I put in parentheses dot or \n, so I believe that would match the whole document so long as you weren't on a Windows machine, because Windows machine does is it /r/n or /n/r? It has a different line break character. So if you were on a Windows machine, you'd also need to add or and that other basically Windows uses 2 line break characters versus Mac and Linux use 1, which is the /n, which is why you guys may have done this either in this class or in 142 or 143. If you try and open one of the documents that we provide you with in Notepad, has anybody tried to do this? Okay, good. I'm glad you guys are not using Notepad. But some people always try and do this in 142 and 143, and they say, wait, why did you write everything on the same line? You know, what's wrong with this? It's because Notepad is a proprietary Windows thing, and it only shows line breaks if they're in the Windows way. If you download some other text editor, it knows that, you probably this file was created by somebody on a Mac or on a Linux machine, and it will respect the just /n line breaks. Line breaks are a little weird in that way. All right. So those are anchors. So we could fix ours here by just adding these in. So let's see, caret and $. There we go. All right. So those are anchors. A couple other things that you're going to find useful. One of them is character sets. So a character set is basically shorthand for having in parentheses a character, vertical bar, a character, vertical bar, so on and so forth. So you write this by just putting a whole bunch of characters, whatever you want to choose between, inside square brackets, and then this will match any string that either has B art or C art or D art. The modifiers work a bit differently inside square brackets. So some of them work the same way, but not all of them. And so like here, like those are gonna work the same way, but I'll show you in a minute one that doesn't. So before we get there though, how would we match DNA? DNA is like a string that's of A's, C's, G's, and T's, and like it can have any number of them. We're not like doing specific. I know there's some like multiples of something that's important, but just any DNA here. How would we do that? Yeah. A, C, G, T, bracket, star. Yeah, I think that would match any DNA. If we wanted to make sure there was at least one character of DNA, right, we could do plus instead. But either of those, that would match DNA. All right. Character that means something different inside the square brackets is the dash character. The dash character, well, you can imagine there's a lot of times you want like alphabetic characters, like A through Z, right? And you don't want to write out A through Z. It's painful. There's 26 of them, right? So instead, you can say A-Z, and that basically means any character A through Z. A really, common thing to do is to say like A-Z, capital A dash capital Z, 0-9. So this will match any lower or uppercase letter or number. So that's, that's a very useful one. Note, we don't put any vertical bars or anything between these sets. We just put them next to each other. The regular expression knows how to handle that. Whoa. Another thing, the caret, that's our front anchor usually, right? if you put that inside a character set, that negates it. So that says, like, caret A, B, C, D means any character besides A, B, C, or D. So the opposite of what it was before. And you, because of this, certain characters have to be escaped in a character set, like the dash, right? Because it means something. So basically, just assume if a character has special meaning in this area, it has to be escaped. All right, so I'm going to practice some more. Yeah?
What if we escape something that doesn't mean anything?
If you escape something that doesn't mean anything, like you try and escape A, then you're going to get an error, because if you write /A, what's going to happen is you write the slash, and then it looks for a, like an escape thing that needs to be escaped afterward, and it's not, doesn't need to be escaped. So then it says, like, wait, this is an invalid escape sequence, because it won't just print this out, because since your backslash has special meaning, it means escape the next thing. In order to print out a backslash, you need to have backslash. All right, so I'm gonna try some of these. So here I've got, let's see, I've got one here where I want to match letter grades. So a letter grade, right, I mean, we don't really do these here, but a letter grade is like A, B, C, D, F. For some reason they skipped E. I don't know, whose idea that was. And they can either have a plus or a minus or nothing, right? You guys are familiar with these. So if I wanted to match these letter grades, how should I start? Somebody just tell me something my regular expression should have here. Bracket A to F. Okay, uppercase A to uppercase F. Okay, so I think that's a good start for us here. Somebody else tell me something else I should have here. One other thing, yeah. I probably need an anchor. Doesn't match E as well. Yes, it matches E as well. So yeah, I think I want an anchor, because otherwise this is going to match any letter A through F in any word. So I probably don't want that. I probably want it to, start with this and end with, the end of it. Okay, and the problem here is that this is going to match E. So I could do like A through D, and then F here, and that would match all those, all the letters I want. Yeah. We shouldn't match C? So we should match C, because C is a valid grade, but we shouldn't match, there's no C++. Like, you can get a C plus or a C minus or a C, but I have yet to find a school that gives you C++. Yeah. Okay, so what sort of bracket? Okay, then plus, minus. All right. And what? Do we need to escape our minus? Yes, we should be escaping our minus in here. All right. And what else? Yeah. Okay, question mark after the plus and minus bracket. So 1 or 0. So looks pretty good. We're matching all the things that we're supposed to match. We're not matching the things we shouldn't match. Do you guys, can you think of any other problems, any other test cases we should try here? I think we're doing pretty well. This should work. There are a couple other ways that we could have written this. For instance, instead of putting both our lowercase and our uppercase in here, we could have put an I after the slash, and that's I is case insensitive. That would have been fine too. Either way, whatever you prefer is totally fine. Yes? Can you do A through F and not E? So you're saying like I could do this and then not E like that. You can only have the not at the beginning. So I could, if I write, let's see, not E here, anytime you have the not, it has to be first in the square brackets and it applies to everything in them. You can't just like make it apply to one. Any other thoughts about this one? All right. Well, let's try another. So now I would like to match UW student ID numbers. So I have a couple UW student ID numbers as examples here. So let's see, I'll make this a little bit bigger. So here we are, we've got some student ID numbers. And so student ID numbers, right, they're all the same length. How could I match a student ID number? Give me just one part of it. Okay, one part. Square bracket 0 to 9. Okay, great. So that matches all numbers. Somebody else tell me something else that I'm going to need here. Yes. Curly brace 7, comma 7, curly brace. So that's going to match exactly 7. And then somebody else tell me, I think we need one more thing. Yes. Anchors, right. So $sign at the end, caret at the beginning, because otherwise this will match exactly 7, but it could have other numbers on the sides. Right. So we could write this a couple different ways. I think one other way we could have done this is we could have said just 7, and that would have also said exactly 7. Either one's totally okay. You'll probably see it written this way more often though. So another thing, I'm guessing another thing the UW database does, although this would be a bit complex for a regular expression we're writing right now, is do you know what the first two numbers of your student ID represent? What do they represent? The year you started at UW, or the year you got your student number. So if we look at these, right, 12, 06, those are valid years. 21, we're not at 2021 yet. So that's probably not a valid student ID, but that would be a little complex for us to check for. Yes?
Do anchors require that the string is on a new line or just separated by spaces?
Do anchors require that the string is on a new line or just separated by spaces? So we can test that out in Rubular. So we could say like this, it doesn't match that. There we go. All right. Let's try, I think, one more. Let's make a regular expression that would match only consonants, and we can assume that we just have lowercase letters. But we want to match only consonants. So, if we wanted to match only consonants, how would we go about doing that? What's one thing? Maybe somebody who hasn't talked yet. Yeah.
Square bracket and then caret all the vowels.
I don't know if Y is a vowel here. I'm never quite sure. It's one half dozen or the other. It can't make up its mind. Okay. Yes, so that is great. So that's going to match all consonants, right? Because that's saying don't match any of these characters. And now if we wanted to match strings that were just these consonants, what would we want to do? Somebody else. So caret at the beginning, $sign at the end. So that would definitely help us match things that just had consonants, but now we're matching only strings of length 1, right? So we'd probably want to say we want more than just one thing. We could have maybe one thing or more, and that could be a plus. Although, we're matching fail, these lines should not match. Do you guys know why we're matching that? It's uppercase, right? So we said, we're only going to care about lowercase things. If we wanted to care about both, right, we could, A, E, I, O, U, Y, and here, then we're not going to match that. But since we're saying not here, well, this didn't have any lowercase vowels in it, so that matched too. Could I also put the /I at the end? So /I here, so that would work too. Yes?
What if there's the line, there's only minus in it?
So so like if I had down here, for some reason my mouse is having trouble. I'm in where? Oh, yes, thank you. I thought they let you do that in there, but no. Yeah, if you had just a dash, that would match, because it's not one of those characters. Alrighty. So we've tried a couple of these, and a couple other things that are good to know with regular expressions. There are some shorthands for common things that you want to match. So /D, this means it's going to match any digit. So basically any number, 0 through 9. Bear in mind it's going to match 1, but it'll match a number. /D is going to match any non-digit. So that's the inverse, right? So you have to be very careful about your capitalization with this particular one. /W matches any word character. The thing that's maybe not so obvious about this one is that it doesn't just match letters, but it also matches underscore and numbers 0 through 9. So this is not equivalent to saying just match a letter. But it can be very handy for things like, an email address, right, is probably going to have some combination of those types of characters. /W, again, is any character that's not one of those. And then finally we have /S. This matches any white space character. So tab, space, new line, other type of new line, it'll match all of those. And /S is any non-white space. So we're just about out of time, but quickly, how would I match last name, comma, first name, middle initial? How about just last name? Yeah.
Square bracket, non-digit, and then
So I could do that. Let's just assume that people can have numbers and underscores in their names for the moment, because like if you're like let's just try it with these particular. But I think you're right. If we were actually writing a name, we'd probably not want to match those. But if we allow word characters, we could say like /W. That's only one character. So /W plus would be like one or more word character for the last name, right? Then we could have a comma. Then we'd want like one or more word character for the first name, and then a space, and then we'd want a word character for the middle initial. Another thing we might want in here, if we were going to be really generous, is we might want to allow people to have however many spaces they want between their first and last name and such. So we could say like /s between these instead of just putting like /s plus in between these, and instead of just putting a space there, because that's like any sort of white space you want, you could have that. Alrighty. I'll see you guys next week. Have a fantastic weekend. On Monday, we will look at how to actually put these in PHP code. Yeah.
In the info text, there are like parentheses for extra information for the book title. Should we also include that in our info JSON?
Yes, so anything, whatever it says in the file, just include it.
And can we use the regular expression in our block thing?
So the regular expression, glob works differently. So glob, you can only use the star. You can't use the regular expression. That sort of regular expression with glob.
Thank you.